Hello, everybody. So we're getting into our worksheet for 9.5 part 1 and 2. If you guys remember, part 1 of 9.5 was looking at trapezoids. Part 2 is looking at kites. That's the front and the back of this worksheet. So let's just jump into it. We start out by being given isosceles trapezoids, with these congruent legs. So just a quick reminder on the rules when we have isosceles trapezoids. Basically, to sum it up, base angles are congruent and diagonals are congruent. All right. And we also have the rule where these base angles, the top and the bottom, they add to 180. All right. And that's basically what this is talking about here. So if you guys take a look at number 3, they're asking us to find this missing angle E right here. All right. You can see the question mark is the angle they're looking for. So on this one, we can kind of make our way over to it. But the idea is, if this angle C is 115, we know that angle D is also 115. And then we know that these, angles, the top and bottom base, they add to 180. Okay, so, you can just grab your calculator and take 180, subtract 115, and it looks like this is going to be 65 degrees. Okay, and that's kind of how these work. So don't overcomplicate these problems. Just be careful with, using the rules. Okay, so moving along, take a look at number 5 and 6. Okay, these are asking us to find the length of the diagonals indicated for each trapezoid. All right, these are extremely easy problems because they're giving us the length of one of the diagonals. On this one, they're saying that RT diagonal is 9.5, or sorry, not 9.5, 9.9. Okay, and they're asking us to find the other diagonal, QS. Okay, all we have to remember is that, again, diagonals of a isosceles trapezoid are congruent. Okay, if one of them is 9.9, the other one is 9.9. Okay, so yeah, at any point, if you want to pause this video and try out some of these problems, feel free. All right, I'm moving on from here. We get into the second part of 9.5 part 1, which was dealing with the mid-segment theorem. So quick reminder on that. All right, basically, here's the idea. The mid-segment of our trapezoid is half the length of the two bases added together. All right, if you guys take a look at, I'm going to do number 9 here. I guess really these first 4 problems are just asking for the mid-segment. All right, so really you could probably just use your calculator to type these in. I'm going to write it out just to make it completely clear. We're looking for the mid-segment right here. It's called FE. Okay, or really you could call it X if you wanted to. And that is equals to 1/2 of the two bases added together. All right, so 26.9 plus 11.1. All right, and so again, this is why you probably could have just done this in your calculator. If I add the two bases, 26.9 plus 11.1, I'm getting 38. Okay, and then taking half of 38 or dividing by 2, looks like X is going to equal 19. Okay, so on these 4 problems, I don't necessarily need to see the work like I just did, but if you want to, feel free. Okay, the next section though, I do want to see the work. These are giving us more complicated values for, our segments here. So let's try number 11. Okay, just first thing to remember when you go to plug in your numbers, the first thing you're going to plug in is the mid segment. All right, on this problem, number 11, the mid segment is this 17 plus 2x. Okay, so that's going to be plugged into my formula first. Okay, and then that equals, 1/2 of the two bases added together. So 1/2 of 19 plus 15. Okay, I mentioned in the lesson that there's 2 ways of going about doing the problem here. I guess before I get into that, though, the first thing we should probably do is combine these like terms in the parentheses. Okay, so let's not get ahead of ourselves. Okay, so we got a 17 plus 2x equals 1/2. And then over here, we got that 19 plus 15, which I'm using my calculator just to make sure, 34. All right, this is where I want to point out we actually have 2 ways we could do this problem. We can, distribute the 1/2 into the parentheses or take 1/2 of 34, or we could get rid of it by multiplying by the reciprocal of 2/1. I think this problem is easiest just to take 1/2 of 34. Don't overcomplicate it. So we got a 17 plus 2x. Okay, half of 34 is 17. Okay, and then from here, we're just solving for x. Remember, we got to get rid of the 17 first by subtracting. Okay, those are gone. We got a 2x equals 17 minus 17. Those are also gone, but 17 minus 17, we're getting a 0. Okay, and then last thing, dividing by 2. I'm just going to do it in my head. 0 divided by anything, we get x equals 0. Okay, just one thing I want to point out. When you guys go to do number 12, be careful with how you plug in your numbers. All right, make sure you're putting your mid segment in the first part of the formula. Okay, cool. So again, if you want to pause the video, try out some of these trapezoid problems, go for it. All right, from here, we move to the backside, which gets into kites. All right, so real quick before we get into the problems, let's just try, or let's recall the 4 kite theorems. All right, so here they are. Diagonals are perpendicular. They cross at a 90-degree right angle. Exactly one pair of opposite angles are congruent. Those are these angles. I call them the wings of the kite. Those angles are congruent. One of the diagonals bisects the pair of non-congruent angles. So these non-congruent angles here and here, all right, this is, diagonal is bisecting those into 2 congruent halves. And then last thing, exactly one diagonal bisects the other. The diagonal that's being bisected is this one. It's being cut into 2 congruent halves. Okay, so with all that in mind, let's take a look at number 3. Okay, one thing to point out, some of these problems are using exclamation points instead of degree symbols. They should be degree symbols. Ignore those exclamation points. If you want to draw in the degree symbols, for some reason, the formatting on these worksheets is just weird sometimes. They get messed up when they get turned into PDFs. But anyway, on number 3, they're asking us to find the measure of angle K. So ultimately, finding this angle right here is our goal. Okay, here is just one thing. I have the angle opposite at this 32, but there's no relationship between these angles. So the question is, what can we get out of this? Well, here's the first thing. I know if this is 124 degrees, this angle E, I know angle I is also 124 degrees. Okay, so there's not enough room to write it on the inside. I'm going to write it on the outside. Okay, but this angle is also 124. Okay, and if you guys notice, all of a sudden, I have 3 of these angles of a quadrilateral. And if you guys, remember, the quadrilateral's angles add to 360. And if I'm looking for a missing angle and I know all 3 others, just subtract them from 360. So that's what I'm going to do. 360 minus 124, minus 124, minus 32. That's going to give me my missing angle. So let me type that in. And it looks like we're getting 80. Okay, so there it is. Okay, and just skimming through these, that's kind of the theme of this section, is using, finding the 3 other angles and then using that to find angle K. Okay, so I'll leave those to you. By the way, on numbers 1 and 2, these are kind of more straightforward. At least number 1 is more straightforward. You can find angle K immediately. Number 2 is going to take a little thinking, I guess, outside the box on that, though I'm going to let you, think about it on your own. Okay, cool. Moving on from here, basically the last section is dealing with more kites. Here's what it says. Use theorem 8.18, like that, that's just the theorems that we deal with. Anyway, and the Pythagorean theorem. Okay, Pythagorean theorem to find the side lengths of the kite and write the lengths in simplest radical form. Okay, so we're finding the side lengths of the kite, all 4 of them. Okay, here's the big thing that's going on these problems, or the first thing to realize. The diagonals of a kite cross at a 90-degree right angle. Okay, and we can go from here and find some of these missing sides. So I'm trying to think. Let's start with this this triangle on number 6. Okay, we know 2 of its sides, and we're looking for its missing side. All right, they told it in the directions, but even if they didn't, this is a Pythagorean theorem problem. It's a right triangle. We're looking for a missing side. We know the 2 other sides. All right, so you guys remember the way I taught it? C squared equals A squared plus B squared? okay, where C is the hypotenuse, which is on this one what we're looking for. That's the hypotenuse. So we're going to plug in X for C. A and B are the other two legs, which they just both happen to be 5 on this one. Okay, so let's see. I'm just going to do all this math together in my calculator. 5 squared plus 5 squared gives me 50. Okay, and then undoing the squaring by square rooting. All right, I'm trying to think. Yeah, let's do what it's asking with the simplest radical form. We haven't really focused on that, but it is something that is good to know. So let me remind you guys on how to simplify the square root of something like 50. All right. So here's what we can do. We can break this thing down into its factors. Okay, and by factors, I just mean what two numbers multiply together to get me 50. Okay, and there's multiple answers to this. Just do what comes to mind first. I'm thinking of 5 times 10. That gives me a 50, right? Okay, a prime number is a number that cannot be broken down into two other numbers. Okay, so 5, I can't break that down. There's only 1 times 5, all right, which still leaves me with 5. So that is a prime number. Okay, but 10, I can break that thing down into a 2 times 5. Okay, cross out the numbers you break down. All right, sorry, I underlined that, but I don't want to do that. Okay, so what are we doing with these prime factors? Well, here's the idea. Pairs of numbers, two of the same numbers get to come out of the radical. Things that do not pair up stay inside. All right, so what's happening is this pair of 5s right here, okay, means a 5 gets to come out of the radical. All right, so just to kind of write it, okay, over here we're getting x equals a 5 is coming out of the radical. Okay, what stays inside the radical, the square root, is what did not pair up, and this 2 is what doesn't pair up. Okay, so a 5 square root of 2 is what we get there. All right, so let's actually go back. Let's write this onto our shape. We know this is a 5 squared of 2. Okay, here's the thing. They want us to find the side lengths of the kite, all of them. All right, here's the good news. The two parts of the two, I guess, sides that are, I guess, connected or adjacent to one another, they're congruent on a kite. So this is also a 5 squared of 2. I get that for free. Okay, but they do want me to go and find these other two sides. So let me just erase this. You don't necessarily need to erase it on yours. All right, but now my focus is going to be on one of these triangles. Okay, and it's the same idea using Pythagorean theorem. Okay, this is still a right angle. This is my hypotenuse. Okay, so let's set that up over here. All right, so I'm plugging in x. Okay, and then 5 and 12 are my other two sides, 5 squared, 12 squared. Okay, so please don't overcomplicate this Pythagorean theorem. I'm just going to do most of this in the calculator. 5 squared plus 12 squared is going to give me 169. Okay, and then from here, solving for x, taking the square root of both sides. All right, and now we can break this down, simplest radical form. Here's something I want to point out. You might have memorized that 169 is a perfect square. But what if we were to break it down? How would we get that same answer? All right, so let's do it real quick. All right, two numbers that multiply to get 169. That to me is kind of a confusing thing to do in my head. So what you can do is you can take 169 and just start dividing it by numbers that go into it evenly. A 2 won't go into this, but I know a 3 will. So 169 divided by 3. Actually, no, it does not go evenly. I was wrong. So I'm going to keep making my way. Let's see. A 4 won't, a 5 won't. Let's see if a 6 does. Nope, not a 6. Let's see. 7, I don't think would. An 8 wouldn't. 9. All right, I'm kind of doing this on the fly here. Let's see. All right, 13. I know a 13 goes into this, and I probably could have figured that out quicker because this is a perfect square. So here's what we know. 13 times 13 gets me 169. These are also prime numbers. They cannot be broken down any farther. All right. So in other words, here's my pair of numbers, okay, that get to come out of the radical and give me my answer. So x is going to equal 13. Okay, so there's my other two sides. So this one's 13, and then this one's also going to be 13. Okay. So yeah, I'm overcomplicating these a little bit because they asked me to put it in simplest radical form, not a decimal. That's why I'm breaking these radicals down and showing you how to simplify them. It's a good skill to know how to do. So yeah, practice those on these others. Put them in simplest radical form. If you have trouble with that, talk to me. Okay. All right, everybody, have a good one.